So in this set of notes, we're going to be doing a deep dive into finding slope using a variety of methods. We've already seen how to find slope on a graph using the rise over run method, and today we're going to see how to find slope given 2 points or given a table. So first, let's talk about what slope really means. Slope is the ratio between the vertical change and the horizontal change of a line. A synonym for slope is steepness. So when you think about slope, you want to think about how steep a line is. We can also think about what direction a line goes in. So for example, we know that a line, first we always read lines left to right. So this line, as we read it left to right, that has a positive slope. And the line below, as we read it left to right, has a negative slope. So slope is going to tell us how steep a line is, but it's also going to tell us its direction. So one of the formulas we already know for slope is m equals rise over run, and we can use this on a graph, and we'll see some examples of this today. Another formula that we have for slope that we can use is called the subtraction fraction. It's m equals y2 minus y1 over x2 minus x1. Now in this situation, these numbers right here are subscripts. They're not exponents. They're below. So what they're showing is that we have two different points on the line. One of my points is xy coordinates 1, and the other point is xy coordinates 2. It's just differentiating between the fact that you have two different x coordinates and two different y coordinates. The 1s are paired together, and the 2s are paired together. You'll hear me refer to this as the subtraction fraction. This is the best to be used when given 2 points on a graph, and we'll see examples of that today. The last slope formula is technically the same as rise over run. It just looks a little more mathematical, and it's the direct, it's coming directly from this definition of the ratio of vertical change and horizontal change. So when you hear ratio, that should make you think of a fraction. Vertical on a graph is our y-axis, and a symbol in math that means change, it looks like a little triangle, and it's called delta. So the way that I read this is delta y, and then horizontal change would be delta x. And so this is saying change in y over change in x, which is vertical change to horizontal change. This is best used when given a table, or you can also use it on a graph. As you continue on, you'll probably see the rise and run formula less and less, and you'll hear it more likely referred to as delta y over delta x. But technically, they all mean the same thing. So then I also know that when my line has a slope like this, horizontal, that's going to be a slope of 0. And from the slope do video, we saw that a vertical line has a slope that is undefined. And I'll show you why I think it's called undefined. So for a positive slope, what that really means is, remember we always read our graphs left to right. And so on a graph, if you're always moving left to right, you're always increasing on the x-axis. So in this case, as x increases as we move left to right, y is also increasing. That would be a positive slope. So as I move left to right, I'm also moving upward. A negative slope, since I'm still moving left to right, so I'm still increasing my x, but this time my y is decreasing. So I could define a negative slope as x increases, y decreases. For zero slope, I'm still moving left to right, and so I can define this as x increases, y stays the same. You could also say y has 0 change if you want to see that word 0 pop up in there. And then for undefined, since my line is not moving left or right at all, I actually can't define it in the same way. So the previous 3 were all defined saying as x increases, something happening to y. And this one I can't define it as x is increasing. So I cannot define it in the same way. I think that's why they call it undefined. In a few minutes, we'll see a few tricks for how to differentiate between 0 and undefined slopes. But for right now, you can know that if it's a horizontal line, it has 0 slope, and if it's a vertical line, the slope is undefined. So here are 6 quick examples to help us review the slope formula, m equals rise over run. And so if you remember thinking like playing the Pac-Man game, if you were standing at this point and you were trying to get to this point, Pac-Man can't go in a diagonal. He has to go either straight up and down or left and right. One way that he could get there is he could go over 1 and up 5, or he could even go up 5 and over 1. In either case, my rise is 5 and my run is 1, and so in this situation, the slope would be 5 over 1 or just 5. And I pay attention to the type of slope the line has, and it's positive. On my next example, I'm trying to get from this point to this point, and again, I can only go vertically and horizontally, so I could draw this in. Now, one thing I noticed this time is that each block is actually scaled by 2. So rather than count 1, 2, 3, 4, I want to make sure I'm counting 2, 4, 6, 8. So my rise would be 8, and in this case, my run would be 4. So rise over run. That's going to simplify to 2. The problem with rise over run that you'll see when we do the subtraction fraction is if the slope is negative, you have to be the one to remember it. So you have to look at this and say, oh, that line is going downward from left to right, therefore my slope is negative. And so the slope is -2. One other thing that's important to remember with rise over run is that it does not matter which number is bigger. It's the up-down number that goes on the top, the vertical number, and the left-right number that goes in the bottom. Regardless of which one's bigger, it won't matter. So at this point, I'd like you to pause the video, try examples 3, 4, 5, and 6, and press play when you're ready to check your answers. So on example 3, between these 2 points, there's a rise of 3 and a run of 4 for a slope of 3/4, and the line has a positive slope. On example 4, the rise is 2, the run is 3, and the line has a positive slope, so positive 2/3. On example 5, there's a rise of 3 and a run of 7, so 3 over 7, and then I also need to recognize that the line has a negative slope, so I need to make sure I include that negative sign in my answer. On example 6, so this line you might have seen depending on the copy. There are tiny points here, but we really tried to actually cover them up, and we wanted to reinforce this idea that you can add points onto the graph and connect. So there's a point here, there was a point here, there was a point here. We were looking for places where the lines kind of crossed at like these corners of the graphing lines. So I happen to use this point, and between those 2 points was a rise of 6 and a run of 2, 6 over 2, which simplified to 3, but then the line had a negative slope, so I need to make sure I include that. It won't matter which set of points you pick, so I could have picked these 2 points even right here, and that would have been rise of 3, run of 1, or I could have picked these 2 points right here, also rise of 3 and 1 of 1. In the end, I'm still going to get a slope of -3. That's what makes something linear, is that regardless of which points you pick on the line, they're always going to have the same rise to run ratio when it's simplified. So the slope between any 2 points is always going to be the same on a line. So now we have a different situation where instead of being given a graphed line, we're given 2 points on the line. So you could make a graph and put these points on it and then use rise over run, or we can use a different slope formula, which is going to be our subtraction fraction. So that formula is m equals y2 minus y1 over x2 minus x1. So in order to use this formula, the first thing that I'm actually going to do is I'm going to label my information to help keep me accurate. So the first thing I remember is that ordered pairs come in XY format. So I'm just going to label them XY. But see how I have an X that's 8 and an X that's 10, and a Y that's 4 and a Y that's 12? It doesn't make sense to use the same variable twice to represent different things, so that's why they use the 1s and the 2s. So 8 is my first X, so that's going to be X1, and 4 is my first Y, so that's going to be Y1. 10 is my second X, so that's X2. 12 is my second Y, so that's Y2. The next thing that I'm going to do, which is my strategy, is I set up this is really the subtraction fraction piece. So I'm going to take this formula, and I'm going to write it, but I'm just going to not write the actual y2, y1, x2, x1. So I'm going to make a nice big fraction with my subtractions. And so I know that this first empty space right here is where y2 should go. The second space is where y1 should go. This space is where x2 should go. And this space is where x1 should go. So in this yellow highlighted region, I'm going to put y2, which was 12. Then in the green highlighted portion, I'm going to put y1, which was 4. In the blue highlighted portion, I'm going to put x2, which was 10. And in the red highlighted portion, I'm going to put x1, which was 8. And now all I have to do is calculate my numbers. So 12 minus 4 was 8. 10 minus 8 was 2, which means my line has a slope of 4. And the main difference between this formula and rise over run is if this answer was negative, it would have calculated out this way. So let's take a look at the next example. So on example 8, I'm going to begin again by putting my subtraction fraction. So a big fraction bar with 2 subtraction pieces. Then I'm going to fill in these empty spots. Actually, what I should do before I do this is even actually label. So x, y, x, y, x1, y1, x2, y2. So then I've got a spot for y2, a spot for y1, a spot for x2, and a spot for x1. And so now all I have to do is put in these numbers. So y2 was 6, y1 was 3, x2 was 4, x1 was -2. The key on this one is that in this blue dot, this blue highlighted dot, went the number -2. This minus sign was just part of my subtraction fraction. It was there all along. So it is possible for these numbers to be negative. That's not going to affect this. Now my next step, in order to actually subtract these, well, 6 minus 3 is just 3, but 4 minus -2, I know I would do keep change opposite, and I would end up with 6. And then I'm going to simplify, and I'm going to get a final answer of 1/2. So at this point, I want you to pause the video. I want you to try examples 9 and 10. On example 10, do not be afraid that there's fractions there. I promise it's going to work out nicely. That doesn't always happen with fractions, but spoiler alert, I promise it's going to be okay. Pause the video, press play when you're ready to check your answers. On example 9, I did -1 minus 2, keep change opposite to get -3, and 4 minus 5, which is -1. -3 over -1 simplifies to +3. So example 9 has a slope of 3. On example 10, I did -3 minus 5, which was -8, and then on the bottom I did 1/2 minus 9/2. And I ended up doing that over here, and 1/2 minus 9/2, I have a common denominator. 1 minus 9, or 1 plus -9, was -8, and then divided by 2 is -4. So those fractions actually came out to 1/2 minus 9/2 was -4. -8 divided by -4 is +2. So let's look at numbers 11 and 12. So on 11 and 12, I'm going to do a quick sketch. So I'm just going to set up a y-axis, an x-axis, and I'm going to graph the point 3, 4, and then I'm going to graph the point -2, 4. I'm going to connect. So just based on my knowledge of types of slopes, I know that this horizontal line has a slope of 0. And now let's do the same thing over here in example 12. So I've got -5, 1, and -5, 3. And if I connect those, I end up with a vertical line, and I know that that has an undefined slope. So the next thing that I want to do is see how the subtraction fraction can help me arrive at these answers, because right now that's what I'm using is my visual of horizontal is 0, vertical is undefined. Now I want to use the algebra. So I'm going to set up my subtraction fraction, and I'm going to do y2 minus y1, which is 4 minus 4. And then on the bottom, I'm going to do x2 minus x1, which is -2 minus 3. And if I were to do that out, what I would end up with is 4 minus 4 is 0, -2 minus 3 is -5. Now let's go over to this other example. So y2 minus y1, 3 minus 1, x2 minus x1, -5 minus -5. And so here I'm going to do keep change opposite, and so I'm going to get 2 over 0. So what do you notice about these two fractions having in common? They both have a 0 in them. But what's different is that this one has the 0 in the numerator, and this one has the 0 in the denominator. One thing you can do is use your calculator to help you. So go ahead and type this into your calculator right now. Pause the video, press play once you have an answer. 0 divided by -5. So hopefully you saw that your calculator just gave you an answer of 0. That's helpful. Now I want you to do the same thing, but type this into your calculator. 2 divided by 0. Pause the video to do that. Press play when you have your answer. What most calculators are going to say here is they're going to say error. That's because you can't divide by 0. So we're not going to say error for our answer, but that's going to kind of be a clue for us to say, hey, wait a minute. If you forget that this is undefined, that, okay, it's error, which means that my slope is actually going to be undefined. I've got another trick for you though. Let's go back to page 1 where we've got those formulas. So in this box here for the 0 undefined, we're just going to add a little bit of additional information. One thing we noticed was that using the subtraction fraction for both 0 and undefined slope, they both ended up with a 0 in the fraction. So for 0, it was 0 on top with a number on bottom, but for undefined, it was a number on top with 0 on the bottom. And there's a little rhyming trick that we can use. If the 0 is under the line, it's undefined. But again, you can also use your calculator. If it's 0 and you type this in, 0 divided by a number, your calculator will say 0, you know it's 0. If you type this in, a number divided by 0, it's going to say error, but we're going to now know that that's undefined. But this is the other trick. If the 0 is under the line, it's undefined. Okay, so let's go on to our last page so we can see how to use our last slope formula, which was m equals delta y over delta x. And again, that delta means change in. So for example, let's say you were trying to find delta T, that might mean change in temperature. And if the temperature went from 37 degrees to 41 degrees, that would mean the change in temperature was 4 degrees. We're just trying to find the difference between. This is the most helpful formula when you're using a table. Now, one thing I could do, I could graph these points onto a graph and use rise over run, or I could set up two ordered pairs in XY format and use subtraction fraction. But to be efficient, we want to try to solve problems in the way in which they're presented to us. So if I'm going to use my formula, m equals change in y over change in x, I need to find the change in y and change in x. So if I look at my x row, x is going from 0 to 2 to 4 to 6. So that means that x is changing by how much each time? From 0 to 2 to 4 to 6 means that x is changing by 2. And so in my fraction, that goes in my denominator. My y is going from 5 to 10 to 15 to 20. That means that y is changing by 5 each time. And so that would go in my numerator. And so my slope would be 5 over 2. Just a quick reminder about slope, we never change it to a mixed number, even though 5 over 2 is the same as 2.5. We want to be able to see rise compared to run, and if you have a mixed number, you can't see those two parts that are a ratio. This is a ratio, a mixed number really isn't a ratio. Let's look at example 14. So again, I'm going to use my same formula, m equals change in y over change in x. And on this one, my x is going from -6 to 3 to 0 to 3, which means x is changing by 3 each time. That's my denominator. And then my y is going from -2 to 7 to 9 to 16 to 25. My change in y is 9. And that would simplify to 3. So you're going to try examples 15 and 16. These tables are just now in the vertical format. So x is in this column here, y is in this column here. But you're still using that same formula. Slope equals change in y over change in x. Pause the video, press play when you're ready to check your answers. So on example 15, x is going from -4 to 2 to 0 to 2 to 4. It's increasing by 2, and my y is increasing by 6. 6 over 2 would simplify to 3. On example 16, my x is changing by 10 each time. My y is changing by 5 each time. Change in y over change in x, which would simplify to 1/2. One thing that we didn't see here, but just to know that it's possible, is that it would be possible for these numbers to be going down, or even your x numbers to be going down. Just know that that means the change would be a negative change, and you would include that in your answer. None of these examples had that, so I just want to point that out.